Just want to go through the lesson on light and optical systems with you. And basically, this is all of the material for the unit. So I'm just going to break it into about 3 videos here so that you can check these out at your own convenience. So we'll just start up this presentation. And just be a moment there. Okay, so light and optical systems, there's a concept map here, and I'll probably share a Google Doc or PDF version of this. And this is just a really good summary of the entire unit. So definitely refer back to this graphic when it comes to getting yourself ready for a final assessment. Okay, so I'm going to try and get through properties of light up until the wave model of light in this first lesson. Okay, so one thing that you should know about light is that it travels in straight lines. Okay, so basically what we have is a ray model of light to help explain some of these properties. So a ray is just a straight line that represents the path of light. Okay, so what we have are ray diagrams, and what they do is they help us to demonstrate brightness or intensity of light through changes in distance. So this will explain how shadows can be formed when an object blocks a ray of light. Okay, so some of the properties of light. So light travels in straight lines until it strikes a surface. Okay, if you've ever taken a brand new piece of aluminum foil, you'll notice that it's very shiny, and in some cases that it's almost, well, it's very reflective. Now, if you happen to crumple that up, you're basically changing the aluminum foil from one shiny surface into probably dozens, if not hundreds, of shiny surfaces. So even if you look closely at it, you'll see that despite the fact that it's crumpled up, you'll have these small, very small surfaces where light can be reflected. Although this changes the way that the light is reflected on the entire material. Okay, so some terms you should be familiar with are translucent. Basically, light will pass through and it's kind of diffused. I always think of it's kind of in between opaque and transparent. So it's kind of like wax paper. If the surface is transparent, light will pass through it. So this will be clear, right? Not necessarily colorless, but clear. Okay. So if no light is able to pass through something, it is considered opaque. Okay, so it basically blocks light from passing through it. Okay, so luminous objects, of course, so there's luminous objects which give off light. Those are light sources, whereas non-luminous objects do not. Okay, we talk about reflection. We have a law of reflection and the type of surface it hits. Okay, so really, how light bounces off of a surface depends on these two things. So light coming from a light source is an incident ray. Okay, so this is your light here. So light is emitted. This is your incident ray. And then what we have here in between what is the reflected ray and the incident ray is the normal line. Okay, so the angle between the incident ray and the normal line is the angle of incidence. So this is the angle of incidence right here. Okay, and you can experiment with this with a flashlight. I've done this before, and you can try that on a reflective ceiling. I know when I was teaching photography, one of the things that I had students do is point the flash. And if you've ever seen a flash on a camera, on a digital SLR, what we used to do was point the flash towards the ceiling. So we point the flash towards the ceiling, and then that kind of basically what happens is it's reflected off the ceiling, and right here would be our subject. So instead of the subject getting that light full on, we prevent that overexposure, so the light is basically bounced off the ceiling and it hits them. Okay, so know what your incident ray is, know what your reflected ray is, what your angle of incidence is, and what your angle of reflection is. Okay, and what your normal line is. Okay, so different types of reflection. So we can get a diffuse reflection when light hits a rough or uneven surface. So this would be kind of like if you have crumpled up your aluminum foil. Whereas if we have our aluminum foil just straight off the roll, it's still very smooth. So light hitting smooth surface, it basically reflects at that angle that's opposite to what it hits. So your angle of incidence, and there's your angle of reflection. Okay, so with reflections, we can get image formation. Okay, so an image is going to be formed in a mirror because light will reflect off all of those points. Because of that, object is being observed in all directions. So the rays that reach your retina, okay, which is the light sensitive part of your eye, they appear to be coming from the point behind the mirror. Okay, so your brain interprets this as a straight line. Okay, and it interprets this pattern of light that reaches your eyes an image of the object you're looking at. So basically what we're seeing here is here's your object that's being reflected, but you can see that this is your angle of reflection right here that's going to reach your eye. And it's as if this image is right behind the mirror. Okay, so for those of you who participated in the Kahoot last week, we talked about concave and convex mirrors. So concave is kind of like it's caved in, right? And just let me fix this image here. Okay, we'll just scoot this over. So the focal point in front of the mirror, okay? So we've got the focal point in front of the mirror. So concave mirrors will basically form an image that is closer than it actually is. And this can be useful because you can reflect light from a large area. So like security devices, flashlights. So if you want to cast a lot of light, so you're basically pushing this light outwards. Okay, so flashlights, car headlights, cosmetic mirrors, and so on. So these will cave in, whereas convex mirrors are going to bulge out. So the focal point is behind the mirror. So basically what you're going to get with this is that images that appear much smaller and farther away from the object. So like rear view mirrors, side mirrors on automobiles, and so on. Okay. So that brings us to refraction. And it's basically this process of where light is bent when it travels from one medium to another. So you can see this when light passes through air compared to water. And we see this, what looks to be like a bending of the spoon here. And you can try this with plenty of objects. So it makes the object's image appear to be in a different position than it really is. Okay, so we can also get refraction happening when light travels through air at different temperatures because, of course, the temperature of air will change its density. So warm air will be less dense than cold air. So it almost looks like the surface is wet. But what we call this I guess is where it comes from, the whole idea of a mirage in a desert. It looks like there's water, but it's actually just the refraction of light through the hot air.